Section 5.4 is on the sum and difference formulas. The sum and difference formulas help us evaluate different points and find more exact values, better representations for their exact values. These are the formulas. The sine of u plus v is sine u cosine v plus cosine u sine v. The minus is similar, but it has a minus sign. The cosine of u plus v is cosine u cosine v minus sine u sine v. And then the cosine of u minus v has an opposite sign. These are the formulas for tangent, although we don't use those as much, but we do use sine and cosine a lot. You will memorize this eventually. It doesn't seem like they'll be easy to memorize, but the more times you're doing sine, cosine plus cosine, sine, you will start to remember. Okay, now for example 1, it says find the exact value of the cosine of 105 degrees. I don't know what the cosine of 105 degrees is, and it's not on my unit circle. But because I can represent 105 degrees using two angles that I do know, which in this case is I can rewrite this as 60 degrees plus 45 degrees. I can use the fact that I do know what the cosine of 60 and 45 are in order to evaluate this more exactly. Okay. So I'm going to do the cosine of the quantity 60 degrees plus 45 degrees, which means I'm using this formula here, okay? In order to evaluate the cosine of 60 degrees plus 45 degrees, I do the cosine of the first angle times the cosine of the second angle minus the sine of the first angle, sine of the second angle. And the sine for the cosine formulas, the plus minus sign is the opposite of what you are evaluating. So for cosine, it's cosine first, cosine of the second, minus the sine of the first times the sine of the second. Okay, this made it look much, much worse, but I know what the cosine of 60 degrees is. The cosine of 60 degrees is 1/2. The cosine of 45 degrees is root 2 over 2 minus the sine of 60 degrees is root 3 over 2. And the sine of 45 degrees is root 2 over 2. So now I can evaluate this. This is root 2 over 4 minus root 3 times root 2 is root 6 over 4. And then we often write our answer as a single fraction. So root 2 minus root 6 over 4 would be the exact value for the cosine of 105 degrees. And there are other ways to, other angles that would add up to 105 degrees, but we would end up with the same result no matter how you evaluated it. Okay, we don't normally use degrees though. We actually normally use radians. Okay, so the next one says find the exact value of the sine of pi over 12. Okay, pi over 12, I don't know what it is, but I want to try to figure out what I can add or subtract to get pi over 12. So let me think. I want to do something over 12 minus something over 12, and I wanted to simplify to get 1 pi over 12. Okay, if I'm randomly guessing, let's say I did 5 pi over 12 minus 4 pi over 12. That would give me 1 pi over 12, but because I don't know where 5 pi over 12 is on the unit circle, it's not going to help me out. Now 4 pi over 12 is actually pi over 3, so I could use that value, but I need them both to be values that are significant to me on the unit circle. Okay, so let me think. Instead of that, I'm going to do 4 pi over 12 minus 3 pi over 12. That still equals 1 pi over 12. 4 pi over 12 simplifies to pi over 3. I know that location on the unit circle. And 3 pi over 12 simplifies to pi over 4. I also know that location on the unit circle. Okay, so I'm going to use that difference to evaluate this. So the sine of pi over 12 is the same as the sine of pi over 3 minus pi over 4, which means now I can use the difference formula for sine to evaluate the sine of pi over 12. Okay, the difference formula of sine is this one, the sine of u minus v, or pi over 3 minus pi over 4. And the pattern is a sine of the first, cosine of the second, minus cosine of the first, sine of the second. And the minus sign in the original problem matches the formula. Okay, so this is going to be sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay, and I pick this because I do know the values for this. The sine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. The sine of pi over 4 is root 2 over 2. And then when I simplify this, I get root 6 minus root 2, and then the denominator is 4. Okay, so this is the exact value for the sine of pi over 12. Okay, now for example 3, it says find the exact value of cosine of u plus v, given that the sine of u is 7 over 25, where 0 is less than u is less than pi over 2, and the cosine of v is negative 4/5, where pi over 2 is less than v is less than pi. Okay, so this is actually incorporating what you learned last chapter with the new formulas. Okay, I'm just going to rewrite the formula for this. The cosine of u plus v, this is cosine. The sign is the opposite, not the sign, the plus minus sign is the opposite. So this is the formula I'm going for. Okay, and now I'm gonna go back and read the problem because I do need the cosine and sine of u, and I need the cosine and sine of v. Okay, so they gave me that the sine of u is 7 over 25. Okay, then they tell me 0 is less than u is less than pi over 2, so they're telling me this is in quadrant 1. Okay, so I do need the cosine in that location, so I could use XYR or I could draw a picture to figure it out, whichever way is easier. I'll just draw a quick picture. Okay, it's in quadrant 1. Sine is opposite over hypotenuse. If I do the Pythagorean theorem, I find that the missing side is 24. And yes, you can stop showing me the Pythagorean theorem every time you use it now. Okay, so the cosine of u is going to be 24 over 25, which I'm going to use in the formula shortly. Now I'm going to look at v. Okay, they tell me that the cosine of v is negative 4/5. They tell me pi over 2 is less than v is less than pi, which is telling me this is in quadrant 2. Okay, you could do XYR for this, last chapter. You could draw a picture, but I'm looking at v over here. Okay, what is it? Cosine is negative 4 over 5. If I use Pythagorean theorem to find the missing side, I get that this is 3, and because it's in quadrant 2, the y value is a positive 3. So they already told me the cosine of v is negative 4/5. I will need the sine of v, and if I look at this picture, the sine of v will be 3/5. Okay, I did all that work just to get ready to actually solve the problem. Okay, so now if I look at the formula, the cosine of u plus v is cosine u times cosine v. So what is the cosine of u? I wrote it down over here. I figured out that the cosine of u is 24 over 25. Okay, now the cosine of v, where is the cosine of v was given to me, it's right here. So the cosine of v is negative 4 over 5. Okay, minus the sine of u. The sine of u was given to me, it's blue, it's 7 over 25. Okay, and then the sine of v I calculated as 3 over 5. Okay, now that I have all the values in place, I'm going to go ahead and simplify this a little bit. So 24 times 4 is negative 96 over 125 minus 21 over 125. I'm going to rewrite this as a single fraction. So I get negative 117 over 125. And they will always have a common denominator if you were wondering about that. So the exact value of cosine of u plus v given this scenario is negative 117 over 125. Okay, now for example 4, they would like us to, it says rewrite, it should say rewrite or simplify the sine of arctangent 1 plus arc cosine of x. Okay, they're again trying to get you to use what we learned last chapter along with the new formulas that we're learning right now. So this is the sine of something plus something, so that's my u plus v. So I'm using the sine of u plus v formula. Okay, if you look back at your formulas, the sine of u plus v is the sine of the first thing times the cosine of the second thing. Okay, and then because this is a plus the cosine of the first thing times the sine of the second thing. Okay, now I have to go through this and try to actually evaluate it. You could draw a little picture. We could do all kinds of things. Okay, to start with, I'm just going to do the sine of the arctangent of 1, which could actually be evaluated using the unit circle, or it could be evaluated by making a small little triangle. I'm going to make a little triangle. Do I have space? I'm going to put it over here. This is my arctangent 1 picture. The arctangent 1 is telling me that the tangent of this angle is equal to 1, so this is 1 over 1. Okay, what's the hypotenuse in this scenario? Well, 1 squared plus 1 squared, that would be root 2. Okay, so then if you recall, the sine of arctangent 1 is saying what's the sine of the angle that produces a tangent of 1. Okay, so the sine of this triangle at this angle would be opposite over hypotenuse, so it'd be 1 over root 2. Okay, I'm going to go ahead and create a triangle for arc cosine x, and so I can use it to answer some of these questions. Actually, I don't even need it for the first one, huh? The cosine of arc cosine x, those cancel out, so this is just going to turn into an x. I will need it for the next one then. Okay, now I'm going to keep going. The formula says plus. Now I'm at the cosine of the arctangent of 1. Okay, I already drew a picture for arctangent 1. Okay, now if I want to find the cosine of this scenario, it's going to be the adjacent over the hypotenuse. So that's going to give me 1 over root 2 times. Okay, then I have to figure out what the sine of the arc cosine of x is. So I am going to go ahead and draw a picture for arc cosine x. I'm going to draw a little triangle. If the cosine of that indicated angle is x, then this must be adjacent is x and the hypotenuse is 1. If I use the Pythagorean theorem to find the missing side, I would get that this opposite side is 1 minus the square root of 1 minus x squared. Okay, so what am I trying to evaluate? I'm trying to find the sine of the arc cosine of x. So I'm trying to find the sine of this indicated angle here, which is going to be the opposite over the hypotenuse. Okay, and then I'm just going to try to make this look a little bit better. Yes, it does normally have a common denominator, if you're noticing that these keep having common denominators. So I have x plus the square root of 1 minus x squared. The whole thing's over square root 2. I am okay with you leaving it like this unrationalized because rationalizing it is not going to help it simplify in any way, shape, or form. Okay, now example 5 says prove that the sine of pi over 2 minus x is equal to cosine x. That's actually the cofunction property that we introduced in 5.1, but just told you it existed. Now that you know this difference formula for sine, you can prove that this is in fact working using the difference formula. And if it says prove, they actually do want you to use other properties to prove that this is the case. Okay, now the difference formula for sine is sine u cosine v minus cosine u sine v. Okay, so let me think. That's the sine first thing, cosine second thing, minus cosine first thing, sine of the second thing. Okay, it doesn't look good, but because I know some of these values, it's going to make it simplify. Now the sine of pi over 2 is 1. Cosine of x, I have no idea. I don't even know what x is. Okay, the cosine of pi over 2 is 0 times the sine of x, which I don't know what it is. 1 times cosine x is just cosine x, and 0 times sine x is nothing. So we did in fact prove that the sine of pi over 2 minus x is equal to cosine x using the new properties that we have found. Okay, example 6 is using the tangent difference formula. We don't use the tangent distance formula a lot, and that's just because if you know the sine and the cosine difference formula, you can find the tangent distance difference formula by doing sine over cosine, and often that's faster and easier. But I'm just going to show you what it looks like if we were to plug into it. Okay, it says rewrite the expression as a trigonometric function of only theta, meaning they don't want it to say theta minus pi over 4, they just want it to say theta, okay, which means I'm going to use the difference formula. If you look back at your formulas, at the numerator it says the tangent of u minus the tangent of v. So tangent of the first thing minus the tangent of the second thing. Okay, and then in the denominator, they have 1 plus tangent u, tangent v. Okay, I'm going to simplify this the best I can. Okay, tangent theta, I have no idea what that is because I don't know what theta is. But the tangent of pi over 4, I do know. The tangent of pi over 4 is 1 because it's root 2 over 2, root 2 over 2. Okay, and then in the denominator, I have 1 plus tangent theta times the tangent of pi over 4. The tangent of pi over 4 is just 1. So I get tangent theta minus 1 over 1 plus tangent theta. And this is a function of only, a trigonometric function of only theta, because whenever I wrote tangent, it just had a theta here as opposed to a theta minus pi over 4. Okay, but that's just to give you an idea of how do you plug into the tangent formula. Okay, the last example is how you might use these formulas while solving. Okay, so it says find all the solutions of the cosine of x plus pi over 2 plus the cosine of x minus 3 pi over 2 equal to 1 in the interval 0 to 2 pi. So I'm going to try to solve this equation, but because of the crazy way it's written, I'm going to have to make it look worse in order to make it look better. Okay, so I'm first going to apply the cosine sum theorem here. And if you remember, the cosine sum is the cosine u cosine v minus sine u sine v. Okay, so cosine u cosine v minus sine u sine v. Okay, plus, now I'm going to have to expand out this expression as well. Okay, this is the cosine difference formula, which is cosine cosine plus sine sine. So cosine x cosine 3 pi over 2 plus sine x sine 3 pi over 2. Okay, and I can normally remember the formula. I remember cosine is the opposite, and cosine always starts with cosine cosine. Okay, let's take a look at this mess and see what we can do with it. Okay, cosine x is here to stay. Cosine of pi over 2 is 0. Sine x is here today, so the sine of pi over 2 is 1. Let's keep going. It's going to look good soon. Cosine x times the cosine of 3 pi over 2 is 0 again, plus the sine of x times the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Okay, let's see what we got here. Okay, cosine of x times 0, gone. But I still have this negative sine x. Okay, plus the cosine x times 0, that's gone as well. And then I have plus sine x times negative 1. So I have another negative sine x. And I'm going to bring down the equals 1. Okay, so after all that, I have negative 2 sine x equals 1. Sine x equals negative 1/2. Am I restricted? Yes, I'm only going from 0 to 2 pi. So after all that, my solutions are going to be 7 pi over 6 and 11 pi over 6.